Okay, when dealing with redundant or inconsistent systems, you don't actually know you've got that's what they are before you start. So you start off in exactly the same way. So we make our matrices. So we're going to have 1, 2, 2, then 11, 1, -1, 3, 8, 4, -1, 11, and 35. Okay, and we're still looking for our triangle of zeros here. Okay, so in order to do that, if we keep the first two the same, first two rows the same, and we do 4R1 subtract R3, that makes that 0. That will make that 8 minus 1 will be 9. That'll be 8 minus 11 will be -3. And then that will be 44 minus 35 will be 9. Okay. Next up, I want to make this 0. So if I just subtract, so R1 will stay the same. And then I just do R1 take away R2. I'm going to get 0. I'm going to get 3. I'm going to get -1. And I'm going to get 3 here. And R3 will stay the same here. And then I would like this 9 to turn into 0. So if I do, remember I can only use these two rows this time for this last one. So I just need to do 3 times this, subtract this. So that will give me, so 1, row 1 stays the same. Row 2 stays the same. But row 3 will be 3R2 subtract R3. So that's going to go to 0. That will go to 0. And look what happens here. -3, that'll be minus, that will give us -3, minus -3 will be 0. And what have we got here? That will be 0. So here we go. It's redundant because we have everything here. We don't have a value for Z here. Okay, we can't get a value for Z, so when you get zeros all along the bottom, this is redundant. Okay, it's not finished there because you can get what's called a general solution. So if you have a general value for Z, and you have this equation, you've got your equations here. If we go to the second one here, that is 3y minus z equals 3. There it is there. Okay. If we change the subject to y, we'll get 3y equal to 3 plus z. Divide by 3, y will be 3 plus z all over 3. So the y, we have y in terms of z. We don't have a value for z, but we've got this is a general answer for z, and we can do a similar thing with x. So if we go to the first one, the first line, the first row, we get x plus 2y plus 2z equals 11. So what we have here is x, and if we put these two in terms of z, so that's going to give us 3 plus z over 3 plus 2z equals 11. What could we do here? We could multiply this out here, so that's going to give us x plus, what's that going to give us? 2 plus 2/3 z plus 2z equals 11. Take the 2 over, take everything over in fact. That will give us x equal to 9 minus 2/3 z minus 2z, and tidying that up, that will give us 9 minus, what would that be? That will be minus 8/3 z. Okay. Okay, so that's what x is. So our solution is x equal to 9 minus 8 over 3z, y equals, what was it? It was 3 plus z over 3, and z just equals z. So that's a general solution. So the system is redundant. Okay.